All objects subjected to the same gravitational field strength undergo the same acceleration due to gravity regardless of the mass of the object, and that was first established by Galileo. Mass is the property of a substance that exerts a gravitational force and is subject to gravitational forces. Weight is the name we give to the gravitational force exerted by one mass on another mass. Weight is a vector and has the SI unit of newtons. Mass is a scalar and has the SI unit of kilograms. Calculating weight. The formula to calculate the weight of an object is F subscript g, force due to gravity, equals mg, where F subscript g is the force due to gravity on the object in newtons, m is the mass of the object in kilograms, and g is the acceleration due to gravity to which the object is subjected. Acceleration due to gravity on other planets. The average acceleration due to gravity on the surface of a planet or other body is directly proportional to the mass of the planet or other body. Therefore, we can write g, acceleration due to gravity, is directly proportional to capital M, where capital M is the mass of the planet or other body exerting the gravitational field. One way to measure the value of acceleration due to gravity at your location is to use a pendulum. The period of a pendulum depends only on its length and on acceleration due to gravity. There are many factors which can affect the value measured for acceleration due to gravity at your location. These include the spin of the Earth, local geology, and elevation above sea level. Gravitational fields. Any object or system of objects can be treated as a point mass with all of the mass concentrated at the center of mass, also called the center of gravity. This is the point at which the mass is distributed symmetrically along any axis passing through it. The center of mass can be outside the object for irregularly shaped objects. All massive objects are surrounded by a gravitational field, which extends from the center of mass of the object in all directions into space, or more accurately, extends from infinity to the center of mass of the object, as it is always directed inwards towards the center of mass of the object. Gravitational field lines represent the direction of the force on a mass subjected to that gravitational field. Gravitational fields decrease in strength with the inverse square of the distance from the center of mass, and this is because the field strength decreases with the surface area of a sphere. So therefore we can write acceleration due to gravity is proportional to 1 on r squared, where r is the distance from the center of mass in meters. Acceleration due to gravity on other planets. Acceleration due to gravity is directly proportional to the mass of the body exerting the gravitational force and inversely proportional to the distance from the center of mass squared. Therefore, g, acceleration due to gravity in meters per second squared, is equal to capital G, the universal gravitational constant, which is 6.67 by 10 to the minus 11 Newton meter squared per kilogram squared. Capital M is the mass of the planet or other body exerting the gravitational field, and r is the distance from the center of mass in meters. Gravitational potential energy. Gravitational potential energy is equal to the work done to move an object from outside the gravitational field of a mass to some point within the gravitational field of a mass. The work done is negative as it involves a decrease in potential energy. So gravitational potential energy is equal to the work done to move an object from infinity, that is outside the gravitational field of a mass, to some point inside the gravitational field of a mass, and at infinity gravitational potential energy is equal to 0, and at a distance r from the center of mass of the object, the gravitational potential energy will be less than 0. The gravitational potential energy between any two masses can be calculated using the formula E subscript P, gravitational potential energy, equals minus capital G M1 M2 on R, where E subscript P is gravitational potential energy in joules, M1 and M2 are the two masses in kilograms, capital G is the universal gravitational constant, and R is the distance between the centres of mass of the two objects in meters. A gravitational potential energy graph is an inverse square graph, and shown here is a gravitational potential energy graph of the Earth, with the radius of the Earth labelled as R subscript E, gravitational potential energy on the vertical axis, and R, the distance from the centre of the Earth, on the horizontal axis. The box A represents the near-Earth surface environment, where the formula E subscript P equals mgh, which is an approximation, is reasonably accurate, as in the area covered by the box A, the variation in G from the Earth's surface is minimal. Thank you for watching.